Okay, so we're going to start on paper 1, problem number 1. And it says the fifth term of an arithmetic sequence is equal to 6, and the sum of the first 12 terms is 45. Find the first term and the common difference. So as soon as you see arithmetic, get your formula sheet out. Frankly, I would be happy if you had your formula sheets out right now so you could kind of familiarize yourself with this. Okay. So you see arithmetic sequence, you go over here, you're like, okay, there's my arithmetic sequence formulas. Okay, so you're going to be using some combination of these. You could go ahead and write them down. So I won't need all of them, but I'll go ahead and write them down so we can look and see what would be useful. Okay, so those are all the formulas that are at my disposal. When you see the fifth term of an arithmetic sequence is, I would be writing down as I read this problem. Okay, so fifth term of an arithmetic sequence is equal to 6, so I would write down u sub 5 is 6, because that's how you write down a particular term of a problem. And then it says the sum of the first 12 terms, so that's s sub 12 is 45. And they want you to find the first term, so that's u sub 1, and the common difference, that's d. Okay, so you don't really have a choice as far as formulas over here, so you can kind of look and see what you have. If I'm using this one, I'd be using it for u sub 5. Okay, so u sub 5 would be 6 equals, I don't know u sub 1. What would I be using right here for n? 5 for n, and then 5 minus 1, so then 4. Okay. Okay, so you see in that problem I'm missing u sub 1 and d. So probably the other one, the sum of the terms, is going to be missing the same two things. So I'll have like two equations, two unknowns. So if you look over here and you're trying to decide which term to use, which equation, you're either going to use this one or this one. Any thoughts? Yes, the first one is right. What made you choose the first one? Okay, the second one asks you to put in u sub n, which if you're talking about the sum of the first 12 terms, then this u sub n would be u sub 12. Okay, so if you wanted to find the sum of the first 12 terms, you could do n over 2 u sub 1 plus u sub 12, but we don't know u sub 12. Okay, so we're going to use this formula. All right. Okay, so we're going to do s sub 12. Oh, okay. All right, so s sub 12 would be, what's n? Nope. We did say it was 5, but for this, when we're doing s sub 12, that means 12 is your n. Okay, so we used 5 over here because the fifth term, and over here we know that we're finding the sum of the first 12 terms, so now n is 12. And then I still don't know the first term. Here, still, we're doing the 12, so 12 minus 1, so 11d. Okay, so basically you have two, oh, and we know what s sub 12 is. What is s sub 12? Okay, so I'm just going to change that to 45. Yes. Yes. d is negative 3 halves, and u sub 1 is 12. That's fine. Okay, so you have 45 equals 6 times 2 u sub 1 plus 11d. And so you guys have some choices there as far as what you want to do. You've got two equations, two unknowns, so I could multiply that through. And I could do, okay, what do you want me to solve for and where do you want me to plug it? Okay, so u sub 1 in this one. So u sub 1 would be 6 minus 4d. So we'll put it in over here. So 2 times 6 minus 4d plus 11d. And we could divide both sides by 6 to start with if we wanted to. It's up to you. We can distribute it. So you'd have 12 minus 8d plus 11d. And then combine these, so 11 minus 8, so 3d. And of course we don't have a calculator, so we're having to suffer. 18d plus 72, subtract 72. Now this is me going over to the side and figuring it out. Okay, because I don't have a calculator. Okay, divide by 18. And I can definitely tell that 9 goes into the numerator and the denominator, so 9 goes into 18 twice. It goes into 27 3 times, so d is -3/2. And once you have that, since we use substitution, we can just go back over here and put in u sub 1 is 6 minus 4 times -3/2. Okay, so here you can reduce. 2 goes into 2 once, goes into 4 twice. So you have -2 times -3, so plus 6. And you get 12. If you want to know where you get marks, it tells you that you get marks. You get 1 mark if you attempt to use either one of these equations. Okay, so it's called a method mark. You don't have to write down what you're getting marks for, I'm just letting you know. Then you get 1 mark for correctly filling in one of these equations and 1 mark for correctly filling in the other equation. You get 1 mark for trying to simultaneously solve it, so I'll just put that where we substitute. So any attempt to solve simultaneous equations, and then 1 mark for getting D and 1 mark for getting U. Did I manage to get 6? 1, 2, 3, 4, 5, 6. So that's, my guess is you probably got this one right. Did you guys get an answer? Uh-huh. For the, yeah, 37.7 is right. Okay. Now I wrote it out a certain way. You don't have to write it out the same way as me. But basically you're talking about what's called a weighted average. Well, it's not even all that weighted because it's not a weighted average, sorry. It's a weighted average if you have like 50 people that score one thing and a different number of people that score a different number. So sometimes they'll do a weighted average problem. But this one, basically they give you the average of the first 3 skiers is 34.1. And then they want you to figure out the 5th skier if it turns out that the new average is 35. So what I did is I said, well, if you average all 4, you're going to get 35. So in other words, add up all 4 scores and divide by 4. I should get 35. Well, as far as what the scores were, I don't know what the individual scores were, but they averaged to be 34.1. So on average, I can just act like they were all 34.1. So I said 3 times 34.1 plus whatever the last guy got and divide by 4 and I'll get 35. Okay, so that's how I set it up. You don't have to set up the same way. You can do any kind of logic. You will see that on my paper I actually did this off to the side. Okay, so you do have to suffer through and do your arithmetic by hand. And then multiplying by 4, so if I multiplied by 2, I'd have 70, double 70, I'd have 140. And then I had to subtract 102.3. Okay, so yes, I do all the crossing out. Okay, and you get the 37.7 seconds. As far as marks, they gave you like 1 mark for method and 1 mark for accuracy if you figured out like the 3 people's total time. And then they gave you a mark if you figured out that this would be the total of all 4 people. So this, actually it was an A1 mark. And then if you got the right answer, that was a mark. Okay, and you didn't have to show it as an equation. You could have just done 35 times 4 and subtracted the 34.1 times 3, and you would get all the marks. You just need to show it. Okay, it says the following diagram shows the curve y equals a sine of the quantity b times the quantity of x plus c plus d, where a, b, c, and d are all positive constants. The curve has a maximum at 1, 3.5. You see that's already marked. Minimum point at 2, 0.5. Okay, just to kind of give you what all these parts represent, whatever you have in front, this value is the amplitude. Okay, the D is easy because that's your vertical shift up and down. The C gives you the horizontal shift, but it's the opposite of what you would normally think intuitively. Just like when we shift anything, parabolas or whatever. So like if it says +5, that's going to move to the left 5. Okay, so it's the opposite. The B is what affects the period. So you have two relationships that come from that. One is period is 2 pi divided by B, or if you solve that for B, it comes out period divided by 2 pi. No, 2 pi divided by period, sorry. Okay, so the graph will work either way, and that's generally how you figure things out. Sine and cosine both have a period of 2 pi, so that works for both of them. Tangent has a period of pi. Okay, so that's just giving you the effect of that. So if we look at our graph, it says write down the value of A. So when you're talking about A, you're talking about the amplitude. So basically, that's from the midline to the top. So if you have a regular sine graph, it goes like this, between 1 and -1. And it goes 0, 1, 0, -1, 0. Okay, so I'll just make the dot bigger. All right, so the amplitude of that is 1. It's the distance from the midline to the top. So if you're talking about the distance from the highest point to the smallest point, that would be 2, and you can cut that in half. That's another way to do it. Okay, so what I like to do is say, okay, how far is it? What's this distance between here and here? What? It is 3. Okay, so that's the distance between the highest and lowest. I just need half that for the amplitude, so that's 1.5. So you can get that by like physically showing it on the graph. You can also say you're just trying to find the distance between the two y values and cut it in half, which is what I did. So 3/2 or 1.5, either way. And that was 1 mark. You didn't have to show any work because it says write down. Okay, so you can just deduce it. Find the value of, oh no, I haven't finished yet, sorry. Find the value of D. So D is the vertical shift for it. It's also referred to as the midline of the graph. The midline is just going to be exactly in the middle. So you can find that out using logic, okay? The middle is also averaging these. So you can do 3.5 plus 0.5 divided by 2. So 4/2. Yeah, sorry. 4/2 or 2. So basically, this is the middle of your graph. And like I said, you can figure out the middle through logic. But from there, from a midline of 2, it goes up 1.5 and down 1.5. So the amplitude here, okay, and the midline is the same as your D. Okay, and you get a mark for that. And you don't have to show any work. So logic or write it out, whatever you want. And then to find B, period is 2 pi divided by B, or, sorry, I should have just written this one. B is 2 pi divided by the period, either way. Okay, so I'm going to do 2 pi, and I have to figure out the period by looking at the graph. Okay, so if you want to look at the graph, you need to go, it needs to go through one full cycle. So like if you start here and go all the way down, you'd have to go all the way back up. I think I'll use a highlighter. Red's running out. Okay, so that would be one full period, but what I'm talking about is the horizontal distance that it takes to go through one full period. Yes. Okay, because it's just from a value of 1 to a value of 3. Okay, so the period of our graph, how long it takes before it repeats itself, is 2. So 2 pi over 2, or just pi. And it was 1 mark for knowing it's 2 pi divided by the period, and 1 mark for getting the right answer. And then the C part, the last thing it asked is asked for the smallest possible value of C, and it's telling you that C has to be positive. And that's because if you shift sine and cosine, you can do a lot of different shifts and land on top of itself. Okay, because if I shift this a period, keep shifting this a period of 2, it would keep landing on itself because it just repeats. Okay, so there's a lot of different choices for the answer. They're specifying so that everybody gives the same answer. Okay, so what I did was I kind of looked at, and I drew it in, where this guy would land right here. Because when you think of sine, it starts at 0 and goes up and then down. Okay, so I wanted to know where would this be and then compare like how much I would have to move it over. Okay, so like where would I be like right at this highest point? Both. What would the coordinates be? Okay, and then when I get to the next little spot, the question is where would I be? Yeah, it's actually negative 1.5. I drew it kind of terribly because it's really pretty narrow. So if you look, the distance between this high point and this landing on the midline is a distance of 0.5. So it would help maybe if I drew it skinnier. But you're just looking for it to follow the same pattern it does over here. So this little guy right here would be negative 0.5, comma 2, which is like the midline. Okay, so if you think about it, if you took the cosine graph, the sine graph, which normally starts here, and move it back negative 0.5, then it would land here. Okay, so in other words, normally it starts at 0, but I'm taking the whole graph, shifting it backwards to negative 1.5. Sorry, I wrote 0.5. Then I would get there. So if you're shifting left 1.5, what does your C look like? Positive. Yeah. Because it's just the opposite when you're shifting horizontally, and it's what you would think shifting vertically. Yes, you're trying to show, my work is showing it on the graph. Other things you're allowed to do that would show it, you can put in all the points you know. Okay, like we figured out B, C, and D. You can figure out all those, and then you could just put in the X and Y coordinate from some point and solve for B. But I don't think I would enjoy that, so I did not do it that way. Okay, so the first part of this one tells you just to shade A prime intersect B prime. So A prime, if you remember, is the complement, so it means everything that's not an A. So you want to shade everything that's not an A, or that intersects with everything that's not in B. So you have to be both not in A and not in B. So when you shade, and well, you guys are just going to have a pen. You're not going to have a highlighter. So you can do stripes, or you can color in, whatever you want to do. But you will have most likely black pens. They have to be blue or black. I believe they'll let you bring your own, but we also supply them. So I don't do it, Miss Thomas does it. Two events A and B are such that the probability of A intersect B prime is 0.2, and the probability of A union B is 0.9. Okay, so first off, you need to figure out where you could label those on a Venn diagram, because that's going to help you figure out the whole problem. So any idea where I would shade for that? Or, well, I don't want to shade it because that would mess up my diagram. But yes, just the left part. So it's like, I'm just going to kind of do this. Okay, this part in here is 0.2. That's the part that's in A and not in B. Okay, so you got that part. All right. And then it says A union B is 0.9. So that means like all of this together is 0.9. So I didn't really put anything right there. What I did was put what was on the outside. So if all of A and B is 0.9, what would I put out here? Yeah. So that's what I did. Okay, so that was how I conveyed this information on my Venn diagram. Okay, and then it tells me to find a conditional probability. A prime given B prime. Well, that's on your formula sheet. A conditional probability, you take the intersection of the two things they give you over the given. Okay, so for me, that looks a little different. It's the probability of the intersection of these two guys over the probability of whatever the last part is, the given that. And that's what they want me to find. It's whatever this part is, whatever the second part is called the given. So it's the intersection of the two things over probability of the intersection of these two things over the probability of the second one. Okay. All right, so do I know anywhere on here what the probability of A prime intersect B prime is? .1, because that's where I shaded. Okay, and that's also what we said, everything that wasn't in A and B. So that guy's 0.1. Okay, and then it says probability B prime, so that's everything that's not in B. Yes. Let's see how he got that, just this and this. Okay, and then that's just 1/3. Okay, so the marks were, you got 1 mark for shading, and then you got 1 mark for method, realizing it was a conditional probability, 1 mark for the numerator, 1 mark for the denominator, and 1 mark for the final answer. The answer to part A is 4 minus 2 square roots of 3. The answer to B is square root of 2 plus square root of 6 over 4. And the answer to C is -1 plus the square root of 3. Okay, so the first part of this problem is really easy because it says expand and simplify 1 minus the square root of 3 squared. And they're only going to give you 1 mark for it. And so you would wonder, are they testing you because they think you're in HL math and you don't know how to FOIL? No, they're not doing this because they think you don't know how to FOIL. They're doing this because somewhere later in the problem, this is going to help you. And that's like a theme. Okay, they ask you to do something pointless and you're wondering why, it's going to help you later in the problem. Okay, so to FOIL this guy out, just do the 1 minus the square root of 3 minus another square root of 3 is minus 2 square roots of 3. And then negative square root of 3 times negative square root of 3 is plus 3. Combine your like terms, and you got your 1 mark. Okay, so that was 1. It's better than nothing. Every single point adds up. So then it says, by writing 15 degrees as 60 degrees minus 45 degrees, find the value of cosine of 15. So in other words, they're saying, scoot up, yes. You're welcome, thank you. So this would be cosine of 60 minus 45. Why did they choose 60 and 45? They're unit circle values. That's exactly right. Well, the reason they're telling me to do that is I don't know what the cosine of 15 is. It's not a unit circle value. But I do know unit circle values for 60 and 45. So I'm going to go and use this little identity. And then I'll be able to find the exact value. Okay, so cosine of something minus something, I'm just going to write the formula out to the side. Okay, and remember when you're doing this on this formula, if you're doing cosine of A minus B, so if you're doing the lower part over here, you're going to use the lower sign over here. So I'm going to be using plus in between mine. Okay, so if it was plus, I'd use the minus. If it was minus, I'd use the plus. On this formula, they match, right? In this formula, they match on top, but they're the opposite on the bottom. Okay, but I'm on this one, and on cosine, it's opposite. Okay, so the formula is cosine A, I don't know if it's going to run off the page there, kind of looks like it. Cosine B plus sine A sine B. And it did run off. I'll try to write it here. Okay. Yes. Okay. So when I do this, I might as well have written it on right there because I don't have room anyways. So for me, this is going to be cosine 60 cosine 45 plus sine 60 sine 45. So I definitely need to know my unit circle values. Okay, so I know the first one's pi over 6, then pi over 4, then pi over 3. Okay, the x values go from 1 to 0, so they're going from high to low. So, yeah, 3, 2, 1. And the y values, you're getting higher each time, just physically, and from 0 to 1. So you'd have square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Does x tell you cosine or sine? Yes. So cosine comma sine. And so I can put all these in. So cosine of 60 is the same as pi over 3, so 1/2. And shoot, this pen doesn't work. And honestly, cosine and sine are always the same, so nobody usually gets those confused for 45. Okay, and sine of 60 would be the y value, so square root of 3 over 2. So really all you have to do is simplify that. It's not that hard, and then you've got your answer. So this is square root of 2 over 4, and then multiply those. That'd be the square root of 6 over 4, and they already have a common denominator. So just square root of 2 plus square root of 6 over 4. So that's not too bad. They give you a method mark for knowing how to expand. Being able to substitute in the right unit circle values, they give you a mark, and then the final answer, they give you a mark. You don't have, like I said, you don't have to write down where the marks come. I'm just trying to help you kind of learn how to get points. Okay, and then the last part is the one that's kind of tricky, but I don't know, it's not that bad except for the last step. It says to find BC, so it wants you to find this side right here, in the form a plus square root of b, where a and b are elements of the integers. Okay, so when you look, basically you've got a side, an angle, and a side. And if it's not a right triangle, you've either got to use law of sines or law of cosines. And the way I decide is I look, if I know a side and an angle opposite that side, I'm always going to use law of sines because law of sines is easier and law of sines is faster. I don't have that though. I don't have a side and the angle opposite that side. So that means that I have to use law of cosines. So if you go to your formula sheet, you have law of cosines. So it's under trig, but it's on the second page of the trig. Okay, so since I'm solving for, this is easier if you're solving for a side. This is easier if you're solving for an angle, because the big C stands for the angle. The little letters stand for the sides. So I'm going to write that down. So c squared equals a squared plus b squared minus 2ab cosine c. And I don't really worry about A, B, and C. I just know it's any two sides and the included angle for the AB, this side. Okay, So I'm trying to solve for C. I just left it C. You could call it BC squared because that's the side I'm solving for. I just didn't want to have to write BC that many times. What's that? Yes, it could be called A because technically, if you were to name this, this would be A, B, and C because when you name, you make the smaller side or the small letter is the side opposite the angle. So that's why I'm saying I don't really care that much about whether it's called A, B, and C. What I care is that this is the third side. These are the two sides I know, and this is the included angle. Now you could rearrange this and make this, since it's A squared equals B squared plus C, but I don't like to rearrange the letters. It seems like a waste. So I'm just going to leave it as C, and these are just going to be my two sides. This is going to be my included angle. Okay. So my two sides are that I know are 2 and square root of 2. So I'm going to do 2 squared and square root of 2 squared, doesn't matter the order, minus 2 times the square root of 2 times the cosine of the included angle, which is 15. Okay. This is not a coincidence. They make all the parts of these tie together. There have been like a billion times I wasn't sure about something and wondered where it came from, and the information was earlier. In an earlier part of the problem. Okay, so we're just trying to figure out this. Square root of 2 squared is 2, and 2 plus 4 is 6. So I'm just going to make that 6. And here I have minus 4 square roots of 2, and the cosine of 15, I'm going to put in what I got on the earlier part, part B. And I think it'd be really wise if I just canceled my 4's. What do you think? Okay, so I've got 6 minus, and I guess I'll go ahead. It does feel kind of good. It is cold, but it also feels good because it was like 75 degrees in here. So distribute square root of 2 times the square root of 2. So 2. And negative square root of 2 times the square root of 6. So minus the square root of 12. And so that's just 4. And I can break this down into 4 times 3. And the square root of 4 is 2, so I can take a 2 out. So you've got this. So then you want to take the square root of both sides. When you take the square root of both sides, how many answers do you get? Well, the question, yes, okay. And it's just going to be 2 of them, though. So you're taking the square root, and yes, that's what they wanted you to catch on to, was if you do this times this and you get 4 minus 2 square roots of 3, then if you take the square root of this, you're going to get this. Okay, so when you do this, it's plus or minus, because when you take the square root, you get 2 answers. But the square root of 4 minus 2 square roots of 3 is 1 minus the square root of 3. Now, it can't be both these answers. Okay, and this is what's a little bit tricky. If you did the positive version of this, this would be 1 minus the square root of 3. You have to know, like, how big is the square root of 3? Is that bigger than 1 or smaller than 1? Bigger than 1. Okay, so if you do 1 minus the square root of 3, that's going to come out negative. And you can't have a side length come out negative. But if you do the negative version of this, then it would be negative 1 plus the square root of 3, and that would come out positive. So this is the one that's the right answer. And by the way, I missed that mark. I just put the positive one. I was like, oh, it's just a positive one, but no. Okay. I can't. That's what happened. I lost a mark there. Okay. So where did the marks come from on this problem? You got a mark for this, because that's what I did on the snow days. I would go back and check my works by the mark scheme, because when I first worked it, I didn't have the mark scheme. I only had the test. And then we purchased the mark scheme so we can make sure and get everything right. Well, first of all, you have to be a school to order it. But I don't know, because when we buy it, we buy the whole year. Like, we buy all the exams on one disc, and then we pass the disc around to all the teachers. So, well, you can find a lot of these things. People post them on the internet. They're out there. I mean, I guess I wanted to get it from the horse's mouth. So M1 was there, A1 was here. Figuring out using the A part gave you another mark, and then figuring out that you wanted to use this one gave you the last mark. Okay, so this is only a 4-mark problem, but it actually takes a fair amount of finesse to figure it out. The one thing that was easy for me to recognize is that I had a problem because I had 2 different bases. So anytime you see an equation and you see 2 different bases, you're going to have to change them to all be the same base. And generally speaking, you go down to the lower base. It generally makes things simpler. So since one of them's base 3 and one of them's base 9, I'm going to take the one that's base 9 and change it to base 3. Okay, if you forget how to do change of base, it's on your formula sheet. Okay, so this is the change of base formula. And basically, if you look at this problem, on this side, it says log base b of a. Over here, this is just a completely different, the c is different, came out of nowhere. So in other words, you can change to any base you want right here. Just do log of whatever this is over log of that. Okay, so the log of this over the log of that. Any base you want. Okay, so when I change this guy, I'm going to leave this side the same, and I'm going to leave the 10, but I'm going to change this to log base 3, so it'll be log base 3, log base 3. And then which number goes here, which number goes here? Six over 9. Okay, it's this one over this one. You can change this to any base you want, literally any number in the world, okay, and then put this over that. Okay. All right, now the next thing that I noticed, so this was a point actually for doing a change of base anywhere in the problem, gives you a mark. And then I noticed right off that log base 3 of 9 was going to be something that I knew, because that's asking you 3 to the what will give you 9? 2. So that is actually just a 2. So I did manage to do that next. So really this is just 10 over 2, which is 5. Okay. Now, like if you have trouble knowing that, like, I mean, obviously I do a little more with logs than you guys do because I do it every year, right? But you could say to yourself, like, you just look and see, is this 3 to the something? So some people find it easier when they're trying to figure out to like, to say like this is 3 squared, and then say that logs and exponents undo each other if you have the same base here, so that that's 2. I like to look at it and say 3 to the what will give me 9. Okay, now 3 to the what will give me 6 doesn't work because it's not a whole number. Okay, so we're just going to make that 10 over 2 into 5. By the way, I still haven't earned another mark. I have not earned another mark. It's only a 4-mark problem. Now, a couple of things that you could do. I could have moved this over so that I could combine 2 logs, but I didn't. Okay, you can create a log. That's something I teach when I do SL math, but I don't know how it's taught in pre-cal. But you can create a log out of a regular number. So let me show you how to do that. You can do log base 3 of 3 to the m, and that is creating an m. Okay, because log base 3 and 3 raised to something, those are inverses, exponents in the logs. So these undo each other, and that is equivalent to m. So you can do that with anything. So if I wanted to create a log out of that was base 7, I would just say log base 7 of 7 to the m, and that would still be m. So that's a way to make it so everything has logs. Okay, and then a couple of other properties that you have, they don't show it to you. It's not on your formula sheet, but you can move. If you have a number in front, do you remember that it can be moved up and be an exponent? Remember that property of logs? Yes, no, maybe? Okay. So this could be log base 3 of 3 to the m minus log base 3 of 2 to the n equals log base 3 of 6 to the 5. And when it's spread out subtraction, it condenses to be 1 log division. Good. So this would be log base 3 of 3 to the m over 2 to the n. By the way, when you did that, you got a mark. And the next mark comes from being able to recognize that this 6 could be 3 times 2 so that it could help you figure out like what the m and the n are going to be. So you'll get A1 if you change this to, that's an m, log base 3 of 3 times 2 to the 5th. Or if you want, you could just write that as log base 3 of 3 to the 5th to the 5th. Well, I mean, it's not too big a stretch when you're trying to figure it out, because on this side you've got 3's and 2's, and you're trying to figure out how to somehow do something with this. If you have log base 3 on both sides, and it's just no other quantities, log base 3 of everything on one side equals log base 3 of everything on the other side, then you can drop the logs. Another way to look at it is you're exponentiating both sides. You could say 3 raised to everything over here equals 3 raised to everything over here. But the same result will happen, which is that the logs go away. And so you're just then looking at this, what's left, and trying to figure out what would m have to be and what would n have to be to make this true. Suggestions for m? Because then 3 to the 5th would equal 3 to the 5th. What about n? -5, because 2 to the -5, if you brought it to the top, would be 2 to the +5. And they gave you 1 mark for that. Did I write all the marks? Yeah. So that's kind of a tough way to earn some marks. That's it. Asked you to find m and n. Okay. You are correct. Okay, this next one's lots of fun because they want you to sketch a graph and you don't have a calculator. And you're quite used to being able to sketch a graph with a calculator. Okay. What are the answers, by the way? Okay. Yes, I will miss you. All right. We're going to sketch. Now, one thing I see is this is absolute value, so that means that this whole thing is going to be above the x-axis. Okay, because whatever I put in there, then I'm going to make it positive. Okay, so all my y values are going to be positive, and then this is just a line, so that's not too bad. So probably if it was me, I would start with y equals x plus 2 because that's really easy to graph. So y equals x plus 2, which is one of the ones I'm graphing here, has a y-intercept of 2 and a slope of 1, so I'm going to go up 1, right 1 for a little while. By the way, you do get a straight edge. We'll give you a ruler on the actual test day. So you don't really that you need to graph this, but you can always extend it. A good rule of thumb is if you're drawing a graph, if it has any intercepts, you should show the intercepts. If it has a max or min, you should show that. But we've shown the intercepts. This is a line. I think we've got that covered. Okay, the next part is the hard part because you're thinking, what on earth is y equals the absolute value of 7 over x minus 4 equals? It does tell you you're going to need the intercepts and the asymptotes, so those are pretty easy to find. How do you find the vertical asymptotes? Perfect. Okay, so the vertical asymptote set the denominator equal to 0, so we have a vertical asymptote at x equals 4. So I'm going to draw that on here. 1, 2, 3, 4. I think that was actually supposed to go through this point. Okay, you should also be able to figure out horizontal asymptotes. How do you figure out horizontal asymptotes? You compare the degrees of the numerator and the denominator. In this case, what? Okay, so this has a degree of 0, this has a degree of 1. The degree of the denominator is larger. What does that make the horizontal asymptote? It does make it 0. If the top was bigger, it'd be going off to infinity. You wouldn't have one. If they match, then you would take the leading coefficients. Okay, so we also need to label a horizontal asymptote at y equals 0. Okay, so we're doing pretty good. They asked me for intercepts, so to find the y-intercept, how do you do that? Plug in 0 for x. So if I plug in 0 for x, I get 7 over 0 minus 4. And then you take the absolute value of that, so it's just 7 over 4. So 0, comma 7/4. So that would be around here. So we've got that. If we were to find the x-intercepts, you would set y equal to 0. And that guy would have no solution. Okay, because that can only equal 0 if the numerator is 0 and the numerator is 7. It's never anything but 7. Okay, so that would not have a y-intercept at all. So that's all the information we have about 7 over x minus 4, and now I have to figure out how to draw the rest of it in. Okay, one thing you know is it's completely positive, so there's not going to be anything below the x-axis. Everything's above. You know you have a vertical asymptote, so you should expect it to go towards the vertical asymptote, and when it goes towards a vertical asymptote, it can either do that by going straight up or by going straight down. Well, in this case, I can't go down, because if I did, I would cross into the negative territory. Okay, but remember the definition of vertical asymptote is as you approach it from the right or the left, you would go to infinity or negative infinity. I only have the choice of going to infinity because I'm taking absolute value, and absolute value makes it positive. So basically, I'm going to tell you what it does. It looks like this and like this. Okay, it's going to be two curves. But if I want to know like a couple of points to help me, I can just plug in a couple of points. Like if I put in, let's go 2. 7 over 2 minus, 7 over 2 minus 4. So 7 over 2 when you make it positive. So at 2, it's at like 3.5. So somewhere in here. If you put in 3, you'd have 7 over 1. 1, 2, 3, 4, 5, 6, 7. Okay, so it can kind of, just plugging in a few points can give you the general shape. I don't really know where it's crossing. I haven't solved for that or anything. I think they might ask me to, but okay, but it looks kind of like that. I know it's got to flatten towards the asymptote and not touch it. So basically you have to, it has to go up towards this and it has to flatten the asymptote. The other's basically reflected on the other side. If you wanted a couple of points, you could put them in. Okay, you don't have to. But just enough to give you the idea. As far as points for this, you get 1 point for the vertical asymptote and the y-intercept of 7/4. You get 1 mark for the general shape with the horizontal asymptote, correct? And you get 1 mark for the, I'm just going to put for the line, you had to have gotten the y-intercept and the slope correct. Okay, so you got 3 marks for graphing it. And you kind of earned them because that's not like an obvious one. So then it says find the exact solutions to the equation. And since we drew both of them, how many solutions does it look like we should have? Yes, there are 3 intersection points, so I'm hoping for 3 answers. If this was paper 2, I would just graph them and find the intersection points and mark them and be done. Sadly, they did not ask me this on paper 2. So the way that you do it is for absolute value. If you remember when you were doing it in Algebra 1, you have 2 possibilities. Either x plus 2 is equal to 7 over x minus 4, or x plus 2 is equal to negative 7 over x minus 4. So in other words, if you get what's under here, that's one possibility, or you could get that, that could come out to be negative, and then you'd have to change the sign on it. So you're basically just setting this equal to the positive version and setting it equal to the negative version. Yes, that's how we're going to get all 3. And this is the one you're using if x is greater than 4, because it would already come out positive. You wouldn't have to change the sign. But if you put in a number that's less than 4, it'll come out negative. And so then you just have to take the opposite of it because it's absolute value. So those are the 2 guys that you're going to solve. Suggestions on how to solve this one? Well, they're really, you solve them both the same way. What should I do? That's true. Okay, so multiply both sides. Okay, so you'd have x squared plus 2x minus 4x, so minus 2x, and then minus 8. And that's a quadratic, so you should get everything on one side. And this one you should dance a jig because it's something you can factor. Perfect. So you would get, when you set each one of those equal to 0, you get x equals 5 and x equals negative 3. Now, one of those isn't a solution because this one is the equation if x is greater than 4. Okay, so this x is not greater than 4. If x was less than 4, it would be over here. Okay, so this is the only solution we got on this side. By the way, we got 1 mark here and 1 mark for the answer. And then we just do the same thing on the other side, only we'll get 2 answers. Okay, so 1 mark for, realizing you got to solve this one. So you have x plus 2, x minus 4 equals negative 7. We already FOILed that. Add 7, so you'd have negative 1. And this is when you say, oh, I am very, very sad because this does not look like it'll factor. And I'm sure you don't need your formula sheet because you guys know way cool songs for the quadratic formula. But if you've forgotten and we're not singing the quadratic formula song in your head, you might go over here and think, oh, it's going to be under functions and equations. And you'll be like, what? It's not there. And then here's prior learning. I'll sing it if you sing it with me. But it is actually under prior learning. So the equation's there. Are you singing it? No? Was he? Oh. Okay, but I'm going to turn it this way so maybe they'll hear you. All right, here we go. They can hear me too. Stand right here. And I can't sing it. So, ready? X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Yay. All right. But if you forgot, which I'm sure you wouldn't, it is on the formula sheet, but you have to go to prior learning. Okay, so you plug all that in, you'll be done with this problem. Okay, Okay, you've definitely done harder stuff in HL math than the quadratic formula. So the opposite of b, so 2 plus or minus the square root b squared, so that's 4, minus 4 times a times c. And I always write that out because I'm afraid I'll get the wrong sign if I don't write all that part out. Over 2. So you get 2 plus or minus square root of, this turns into a positive 4, so 8. You can break down the 8 into 4 times 2. So you'd have 2 square roots of 2 over 2. And since 2 goes into all 3 terms, you can cancel. Where? Here? I changed it to plus plus because it was minus minus. So this is just 1 plus or minus the square root of 2. And those are your other 2 answers for the intersection points. So this was M1, A1, so a method and an answer. Okay, I solved this question correctly and got all the marks, but they did it much more elegantly and much shorter than I did. So I'm going to show you the way that they did it in the mark scheme, and it's actually not that bad. Okay, so it says O, A, B, and C are distinct points such that vector OA is A, and that's A with a line over it because it's bolded. OB is B, OC is C. It is given that C is perpendicular to AB. I'm going to write that down because that sounds important. Okay. And B is perpendicular to AC. And they want me to prove that A is perpendicular to BC. So that's what I've got to come up with. Well, what thing did I tell you was really important for you to know about vectors and perpendicular, and what is 0? Dot product is 0. So that's what we need to know from this. So basically we know that vector C, the dot product of C and AB, has to be 0. Well, we can write C is fine. Wait. Oh, I thought you said, oh, it was pain. I thought you said, oh, like I need to wait. Okay. You can write vector AB, sorry, this is a dot, as vector B minus vector A, because that's like doing the end minus the start. And then you can distribute your dot product. So you would have C dot B minus C dot A equals 0. And then I'm just going to add that over to the other side. So I'd have CB equals C dot A. You've got 35 more days. Maybe, depends. Not every course has vectors in it. All right, I'm basically going to do the same thing over here. Okay, since these two guys are perpendicular, I'm going to say that their dot product. No, I don't have the evidence for the end answer. Okay, what do you think I'm going to put instead of AC? C minus A. Okay, and then distribute. So B dot C minus B dot A equals 0. Add it over. Now, if you'll notice, these two both have B's and C's in them. And they're dot products. So I have a question for you. If you do a dot product, is that commutative? Yes, it is. Okay, because you're multiplying the x's plus multiply the y's plus multiply the z's. That's going to be the same no matter which order you do it in. So the dot products are commutative. So you have that these two things, if you have two different quantities that are equal to the same quantity, they're equal to each other. That's the transitive property. So you know that BA is equal to CA. So if you have two different quantities equal to the same quantity, they're equal to each other. And then I'm going to bring this over to the other side. Yeah, these are all supposed to be dots. My fault. Thank you. There's actually a... Yeah, but I didn't write one, so I was missing it. I actually, like if I missed one, maybe not, but there is a part in the mark scheme that says if they didn't do dot products, they lose a mark. But I mean, like, they're not so bad. If they see that you're clearly doing it the whole time and leave one off, they're not like that picky. Same, actually, it literally says, I could pull up the mark scheme, it says to excuse, on this one it says to like forgive the lack of arrows. But it specifically also says not to excuse the lack of the dots. So, anyhow, okay. If you take the A out, the A is actually, yes, in the back. So I'm going to write it like this. So I have the dot product of these two things is equal to 0. So that must mean that these two quantities are perpendicular. And this quantity is A. If I did C minus B, what is that the same as? Yes. Which is what they wanted me to prove. So they gave you some marks. They gave you a mark here. They gave you a mark here. They gave you a mark here. Yeah, M marks are method marks. Here and here. Okay, so we're going to skip to number 10 because I think I can finish it. It says find the x-coordinates of all the points on the curve, and it gives me an equation for the curve, at which the tangent to the curve is parallel to the tangent at -1, 6. Okay, so what do you think the first thing I need to do is? And how do you figure out a tangent line? Well, that's true. You're giving me the equation, but what's the very first thing I'm going to need to know for all this tangent and parallel and what am I trying to find? Slopes. How do you find slopes? Derivatives. I need to take the derivative. Okay, this is just power rule. So tell me. Okay, so that's the slope everywhere, and it says I need to find all the points at which the tangent to the curve is parallel to the tangent at -1. So I need to figure out what the slope is at -1, and then figure out all the other spots that also have a slope of -1. So I really only have to deal with the slope. I don't need the whole equation of the tangent line. So we're going to put in 1, and no, -1, sorry. Don't have a calculator, but we know -1 cubed would come out negative. -1 squared would come out positive. This would just be -1. Okay, so -8 plus 18 would be 10. 10 minus 7 would be 3. 3 minus 5 would be -2. Another mark. So basically, we want to figure out all the places where the slope is equal to -2. Now we know one of them. At -1, there's a slope of -2, but there's some other spots. Okay. So what I'm going to do is bring everything over to one side. So add 2, so that'd just be -3. Now I need to factor that or something. Okay, well that's cubic and really, really hard to factor. But the thing is, I already know that -1 would go into it perfectly. So x plus 1 is a factor if -1 is a root. But what I'm going to do is do synthetic division. Okay. You can do long division. Would you like me to do long division? Okay. Okay, well, if you want to do long, you just be doing x plus 1 into it, and it will come out even. Now, the first one, you bring the number down, and then you do the bottom number times what's in the box, and then you add going down. 10 times -1, so -10. Add going down. -3 times -1, add going down. Now, we knew it was going to come out perfect. Okay, so this gives us 8x squared plus 10x minus 3 equals 0. By the way, you got a mark for realizing that x plus 1 was a factor so that it would reduce down. And then a mark for knowing to go ahead and divide by it. And then as soon as we figure this out, which it'll factor, we'll get a method point and an answer point. So I'll give you the... Well, you could use quadratic formula. It would work. But this one factors. So I'm going to go 3, 1. Want it to be plus 12 and minus 2. So just solve each one of these. So you get x is -3/2 and x is 1/4. And this was an M1 and A1. So this wasn't really a bad way to earn points.